Hi, my name's Ian. I'm an engineer. I'm a dad. I've done some business and consulting, and I make videos about this molecule here, nitrogen and hydrogen. Together, they make ammonia, and you can make it with green power, and you can use it as fuel. Um, so I was down presenting at a green hydrogen conference in Houston, and I want to bring back some of the things I learned. So, green ammonia. Uh, First step, you run green power through electrolyzers water and you get green hydrogen. Second step, you take nitrogen from the air, you put it together with hydrogen uh, under some pressure, under a little bit of heat and a catalyst, and that produces green ammonia, nitrogen and hydrogen. Now, the reason you do this second step is liquid ammonia is a liquid. So it has 6.4 times the energy in a volume in a tank as 5,000 psi hydrogen. Liquid, really, really high pressure hydrogen. Okay, that's the difference. So handling gas is just very different than handling liquid. And I was down there and I'm just asking around just to make sure I really understood where we were. Well, we know how to make green power. That's done. Green hydrogen, we know that it's done. Green ammonia, it's done. Ammonia distribution. We actually use a lot of ammonia already. We use 100 million barrels of oil every day, but we also use 5 million barrels every day of ammonia. So, I mean, the distribution's done. There's pipelines and tanker ships and tanker trucks and the ammonia storage, the buffering, it's done. Those tanks, you can just buy them off the shelf. So really, I think the last thing is developing demand for green ammonia as a fuel. I think that's where we are. Right? Now, when I was there, I was interviewing a panel of experts. CF and Dyno Nobel, they make green ammonia. They make quite a lot of green ammonia. They also make gray ammonia and blue ammonia, but they make green ammonia. And McDermott is an engineering design build procure company. So they will, if say you're a green power company and you want to make your own ammonia, they'll make you the plant and show you how to run it. Right? So I was asking this group of experts about the difference between dealing with hydrogen and dealing with ammonia. I'm thinking about it from a consumer perspective, what would you rather handle? Which would you prefer as a fuel? Hydrogen, ammonia, right? And the answer I got back was absolutely definitive, right? Hydrogen, every part of it is difficult and expensive and dangerous. Hydrogen, dealing with really high pressures is incredibly dangerous. A leak at 5,000 psi or 10,000 psi, it will cut your house in half. It will cut your car in half. It's really, really dangerous. Hydrogen, it's odorless. So if you walked into a cloud of it, you wouldn't notice. There's no warning signs. It's incredibly explosive. So different fuels are flammable in a different range of air fuel mixtures. So some things you need the precise ratio to get it to burn. And other things are flammable over a really wide range. It's the difference, if you light alcohol on fire, it will burn and burn and burn. You can't really blow it out, but a candle, you can blow it easily. It's so not everything that burns is the same. Another challenge with hydrogen is it's a tiny, tiny, tiny molecule. And because it's so tiny, it will leak through everything. If you have a water valve, it prevents water from leaking through, doesn't prevent hydrogen. hydrogen will go right through that seal, right? So, which gets back to the odorless and explosive problem, right? Now, it is non-toxic, right? So if you came in contact with it, you'd be okay, unless you blow up, but you'd be okay. Um, and because of all of this complexity, it's very expensive. Any equipment to deal with this is very, very expensive. The valves you need to use are just wildly different than what you would use in any other circumstance. Everything's just expensive, expensive. Compare that to ammonia. Ammonia, an ammonia tank, it's low pressure. It's like a propane tank. So if it's damaged, the pressure jetting out of it isn't going to hurt you, right? It's not going to cut your car in half. Um, it's very smelly, very smelly. So leaks are obvious. And and under the concentration where you can smell it, you're not getting hurt. Okay. It's you smell it long, long before it would actually hurt you, right? It's very difficult to ignite. You can burn it, but getting it to burn is a real challenge. It's easier to contain because it's a larger molecule. Regular sort of seals work. It is toxic if you're exposed to a big quantity. The treatment is water. Um, so because it's low pressure, because it doesn't leak, the equipment really, it's not expensive. All right. So it's just wildly different hydrogen and ammonia. Now, I wanted to take you through some safety info I found because those comparisons don't really show you examples of dealing with ammonia. So this first video, I'm not going to show you the video, but I will give you a link. This is all from YouTube. It's showing rescue training. So this is training. This is a simulation. What they're simulating is an ammonia truck is damaged in a car accident, and there's a car sitting right there getting blasted with ammonia. So what do, right? It's flammable, it's toxic. What do you do? Well, here what the firefighters do is they approach from upwind with a fan and they blow the ammonia away from the car so that they can pull people out. The firefighters or the rescue training people, they have masks on, which have goggles and ventilators, gloves on, long sleeve shirts. But 10 feet behind them are people not wearing any masks, any goggles, or anything. So if you're directly encountering that cloud, you need protection. If you're a couple feet away, they're not taking any PPE. This is a similar training simulation. Here you have a nursing tank, a tank of a lot of ammonia, and it's blasting a dummy, right? So it's directly shooting out at somebody, simulated shooting out at somebody. Now, what they're going to do here, so you have some training people approaching from upwind, and they have a tarp, okay? Because that jet isn't really high pressure. And the tarp, they're going to put over it, and it takes that cloud and it's going to knock it down so it's a liquid on the ground. And then they'll be able to go get that person and rescue them. The people with the tarp are wearing protection. The people surrounding and taking videos are not, right? They're upwind and they're not worried. So here they are with the tarp. They weight it down with some logs or sandbags or whatever's around. You can see this guy with the camera watching, and they'll go in and rescue this person, right? So use a tarp when it's blasting out. This is a similar case. It's out in a field, but training again. It's a pressurized release. So what they're going to do here is they put a box in front of it, which is going to absorb some of that jet pressure. They put a box in front of it, and then they're going to put a tarp over top, which is going to knock it down. And then from there, so these are pressurized releases, right? Blasting out, which is different than this case. This is just a liquid sitting on the ground. All right. So here, what they were doing was they were measuring sort of the vapor cloud. So they put a bunch of ammonia in trenches, and they're measuring around it to see what the shape of that cloud looks like. So here we have a guy 150 feet away. He can't really smell it at all. This guy 50 feet away, his mask is off. He can smell it, but it's not hurting him. So once it's knocked down, once it's not like jetting out of something, if it's just a liquid on the ground, it's lighter than air. Sorry, it's lighter than air when it's warm out. If it's really cold out, it might sit there. But basically, it goes up into the air when it's in a low concentration. So, just part of the air. It won't hurt anything. It won't hurt birds. It won't hurt anything. Really, it's dangerous in high concentrations because what it does is it sucks the liquid out of you. Ammonia wants to bond with liquid, so it will like dry out your eyes, dry out your mucous membranes, dry out your lungs in a high concentration. In low concentration, you wouldn't feel it at all, and it's not going to hurt you at all. So, because it's a liquid or a gas, it kind of boils. And this is why they use it in refrigerant. It will change state right around -20 Celsius. So as it evaporates, the remaining liquid will drop in temperature and it will get cold. So this guy is measuring how cold the liquid in a bucket of ammonia is. And he's doing it, he's got a glove on because the bucket's cold. And he's got a thermometer in the bucket, but he's not wearing a mask. In his other hand, there's no glove on. Right. So you can smell it, but right there with liquid ammonia, he'd be more worried about that it's cold, really. This is an interesting video. They're demonstrating how difficult it is to light ammonia on fire. So here there's a bucket of ammonia, so it's a liquid, and it's vaporizing off, and so you have some fumes. And then there's a propane torch blasting it. But the propane flame is invisible. So they take a paper towel and put it in front to show you that the propane is going. And they're trying to catch the ammonia on fire. And they're having a real hard time doing that. So even with a flame directly blasting a bucket of ammonia, it's not burning. This is a different experiment or demonstration. They put ammonia and air in a piston and they smash it together. And that force and heat will get it to ignite like a diesel engine. So you can make it burn, but you need an air fuel mixture, you need some pressure, you need to control the circumstances. So in this little demo, it's a glass piston. I've never seen that before. It's pretty neat. So you can see it working. But you'll see, they don't have masks on. They're in a room, no gloves on. So it's a small concentration, small bits are not. Sorry about that. I'm gonna leave it in. I'm gonna leave it in because I'm almost done. All right. So across all these videos, there's some consistent insights, all right? Ammonia safety, um, some critical things, knowledge. If you want particularly your rescue people to know things like when do you apply water or not. Okay? Um, if you're in a really high concentration of ammonia, so let's say an enclosed space, um, having the right masks with the right filters, they're available. We know exactly what to buy, but we should have them. Gloves, it will suck the moisture out of your eyes, so sealed goggles as well. Gloves, goggles, long sleeves. And if you're exposed to ammonia, like if it's directly sprayed on you, uh, you want fresh water. So you're gonna just irrigate and irrigate and irrigate for like 15 minutes, and the water will help sort of suck any ammonia that's absorbed into you out back out of you. All right. Um, but I mean, it's just it's labeled as toxic and people get scared by that. But the reality of dealing with it is just not. I mean, think about how dangerous gasoline is. It's so explosive. If you put it in a trench, you have a lingering problem as opposed to ammonia, where once the spill's been there for 5 days, it's no longer a problem. It's just evaporated and gone. So, um, in my view, and in the view of these experts, do you want to deal with hydrogen or ammonia? There's no real argument. Ammonia is wildly easier, wildly easier. So I actually take that as good news, right? Why is that good news? Because it's easier and it works better as a fuel because it has higher density. So the solution keeps winning. It keeps being the preferable solution. There's no real downside to this. 100% green fuel available and proportionally one of the safest options we have. I'll leave you with that thought. Cheers.